I will start then immediately. I'll be speaking today about Krishna and the Quark, which is my upcoming book on that will be published by the BBT. And see, I will only be able to touch on a few things on it because it would be too much to go over it. So the title is Krishna and the Quark, and I'll be mainly speaking about space, time, and a little bit on matter. So let's start with time. I wish it did not have happened in my time, said Frodo. So do I, said Gandalf, and so do all who live to see such times. But that is not for them to decide. All we have to decide is what to do with the time that is given to us. And if you're a Tolkien fan, you will know that this is from the Fellowship of the Ring. So what do we know about time? And it's something so common, but we really have no idea of what it is. And let us look at some of the questions that have been asked by not only physicists, but also philosophers throughout time. One is there such thing as fatalism or predetermination? Basically, is my future set? Can I do anything about it? And the Greeks wrote a whole drama called Oedipus. And in terms of physics, we hear about, well, there's a deterministic view that, well, the laws of physics, if you give it, here are the laws, and if you give it the initial conditions, it will tell you exactly what will be in the future. Now, you may have also heard about chaotic systems, which are still deterministic. They will still tell you what is in the future, but maybe it's not tractable, such as this spiral that you see here. Yes, it is deterministic. You can compute it, but can you track it down? Probably not. And then there is quantum physics, which is a truly random system. So in these systems, this idea that you can completely foretell what something is going to be in the future goes out the window. Then there is the time freeze. Is it possible to freeze time? Basically, if all of the world, all of the universe stopped for, let's say, an hour, and then went back as if nothing had happened, would we ever know about it? Well, if this is possible or not really has to do with the idea of, is time relational or absolute? And this goes back to Isaac Newton and Gottfried Leibniz. Newton had the idea that there was an absolute time. So in this sense, yes, he would say there is an absolute time, and time freeze is possible because that time does not need the objects in it to exist. On the other hand, Leibniz said, no, time is relational. It only exists as a relation between objects. If you take out all the objects, there is no time because there's no relation. Then they argued this back and forth, and it's still to the end of their lives. There was no consensus. What is the topology of time? Is time branched? Is time linear? Is time cyclical? Is it continuous? What is it? So Newton, he said time is absolute and it's linear. Einstein saw it as relational and continuous. Basically, he merged space and time and into a space-time continuum. Hugh Everett, another physicist, he talked about the branched multiverses. Basically, in every time that you have a universe, and it can there are different possibilities. For example, this man talking to this girl, giving her a flower. In one universe, she blows him off, and in the other one, she falls in love with him. And there are so many different possibilities that go with it. And with each possibility, there's a different universe that happens. So that comes from Everett's multiverse. And now it's so common in the MCU. And then we have quantum loop gravity, which is one of the proposals for the beyond the standard model of today's physicists, and in which space-time is seen as discontinuous, basically like a space-time foam, uh, going from one point in time to another. If you go small enough, you won't have there will be a point at which you just jump from one instant to the next. That's their proposal. Then we also have the idea of time travel, which excites the imagination like no other. Well, special relativity talked about the possibility of going forward in time, and as you see here, we have the famous twin paradox, in which two twins, uh, both living on Earth, one of them gets in a spaceship, goes and travels out at near the speed of light and comes back. Well, because traveling near to the speed of light, one ages here on Earth much more than the one that went on the trip. So going forward in time, that has been proved with cesium clocks, and they have put him one here on Earth and one on a plane, and they saw that yes, you can go forward in time that way. But going backward, is it possible? Well, you would have to go to general relativity, where they talk about wormholes, where you can, if you go through a space-time wormhole from the present to the future, or you can go from the future to the past. Um, are they traversable? We still don't know, because we would have to merge together the ideas from general relativity and from quantum physics. But you would have problems like the grandfather paradox, which we don't know if uh, could be resolved or not, which is the idea that if you go back to kill your grandfather, then how do you explain your existence, right? And is it possible? Well, to be able to have a possibility of having time travel, you would have to talk about the space-time worms. Basically, the idea that there's a version of you continuous throughout time. So just as you exist right now, you existed before and you exist in the future. Now, is that actually the case? We don't know. Uh, but let's say that it is the case that a version of you exists constantly throughout time as a space-time worm. Well, you would be just like one slice of this, that would be the present you. But then how do you talk about the arrow of time? Like if you're the space-time worm, what is making you believe or perceive that time is going forward, rather than just like constantly experiencing all of time at the same time? Why do you experience only time in the forward? So physicists have talked about entropy and the second law of thermodynamics being that arrow of time which points forward, in which the bigger the entropy, the more you go. But why would that be the case? We don't know yet. And finally, we have the question of, is time an illusion? Well, we have people like Price, which is his philosopher, and he talks about how the projection of the mind, time is a projection of the mind to add a subjective experience. But then you have a physicist like Marco Polo Calamara, who says that actually we should wait off in talking about these things, because general relativity is not the final theory of time. Now let's go into space. Here's a quote from Walt Whitman: "Every cubic inch of space is a miracle." Again, we have Newton and Leibniz. Newton, likewise, he said that there is an absolute space. And so if you take everything out of it, there will still be space. And Leibniz said, no, space is relational, just like time, in which if you take all the objects out of it, there is no more space, because space only exists as relations. Einstein later on went to talk more and encourage the idea of Leibniz that space actually is relational. The way that he did it was saying, well, if you have a map is drawn on a paper, on a piece of paper. So the piece of paper is the space-time. And that paper doesn't really, it's useless. What really matters here is the relation between one piece of matter and the next on the metric, right? The metric of the map. So that's how Einstein saw it. And furthermore, we talk about, as we're talking about space, we talk about, is it possible to travel space, basically interstellar space, going from here to other star systems. Well, ideas have been proposed like solar sails, in which you use the solar winds to propel with a special type of sail. Nuclear-powered engines or antimatter engines that will hopefully use very little fuel, but give you a lot of power for a long time. Then there's the idea of traversable wormholes, just like we saw in the previous slide about these wormholes connecting to points in time. It can also connect to places in the universe. But are they traversable? Are they not? Again, we don't know yet because we don't have a theory that connects general relativity with quantum physics. And finally, we have ideas like the Alcubierre bubbles, in which you bend space-time in such a way that even though this ship stays put in this local space, the space itself moves faster than the speed of light. So according to this, you would not be moving really, but the space around you would be moving at the speed of light. So what can we say about this from the point of view of the East? Well, here's a quote by one of the founding fathers of quantum physics, Werner Heisenberg. He says, "Quantum theory will not look ridiculous to people who have read Vedanta." There's Sankhya, which is one of the 6 systems of classical philosophy of India. And for Sankhya, time is not fundamental, nor is it real.
Mauricio, we wrap up in a minute or so, if possible?
Okay. So for them, space is also not fundamental, but it is real. They talk about Akash, which is related to the modern idea of space. And so we see here that there are many different evolutions till you finally get to space. Vaisheshika, on the other hand, which is another system, says that time and space are fundamental and perceived only indirectly. And as you see here, space comes much in another thing, but they are fundamental. Is it possible to travel to the past? According to both Vaisheshika and Sankhites, they agree that time travel to the past is not possible. But for Vaisheshikas, it's an impossibility of relations, while for Sankhites, there is no past to go to because there's only the present moment. Space and time in Vedanta. For Vedanta, like in Srimad Bhagavatam, we see that space and time emerge from Vishnu, as you see here. From Vishnu comes pradhana and comes time. Space is derived from pradhana and time. Space would come down here. So time is not a byproduct or a parameter like in Vaisheshika, but it's an essential ingredient that propels change. One interesting thing that we can see is that in Srimad Bhagavatam, they calculate time from the atom, which is something that is done nowadays, such as in cesium clocks. The topology of time in Vedanta is cyclical, as you see here, cycles within cycles. And can space and time be combined? They're correlated, but they have different natures. We have dancing in a time freeze. So there is a time freeze. They do have time freezes, but there's only time travel in one direction. There are wormholes in the Puranas, And we see that especially in the Kumbh Mela, where they use the Ganges, the river Ganges, to go from different places in space. And yogis, they travel interstellar. They do interstellar travel by changing the composition of their bodies, going from Earth, uh, the and evoluting it back to water, back to fire, back to air, and finally to space. And when they get to space, their bodies are no longer impeded by time or space. I'm going to skip this for now, and so just I can keep to time. And I thank you for your time.
Thank you.